revise on long division of numbers first. So how we can do long divisions for numbers? We have 297 and want to divide by 9. Okay, 2 cannot divide by 9, but 29 can divide by 9. So you have 3 lots of 9. So you times 3 and 9, you have 27. And then 29 minus 27 give you 27, 2, and then you move the 7 down, you have 27 again. 27 divided by 9, you have 3. Then 3 times 9, okay, the new 3 times this 9 will give you 27, and you have remainder 0. Okay, if you have remainder 0, there are 2 ways you can write this result. Okay, the first way will be 297 equals to 9 times 33. Or 297 divided by 9 give you 33. Okay, because the remainder is 0, so it's easy for me to write the result. Okay, so the 297 equals to the answer times the dividends. Okay, the answer times the dividends. And let's do the second one. The second one is 2178. I'll use that divide by 7. 2 is not enough divide by 7, so we'll think about 21. So 21 divided by 7, you have 3. So 3 times 7 will be 21. Okay, now you have a 0 here. Okay, so you bring the 7 down, you have 0, 7. Okay, so 7 divided by 7, you have 1. So 1 will go to times the 7, you will have 7. So you have 0 here, which then you bring this 8 down. And 8 divided by 7, you have 1. Okay, 1 times 7, you give your 7. So 8 minus 7, you left with 1. Okay, this is the remainder. Okay, this is the remainder. You have 311 of 7 in 2178. Also, you left with 1. So there are still 2 ways to express this answer. 2178 equals to 311 times 7 and plus by 1. Okay, so 2178 equals to the answer times the dividend and plus the remainder. Okay, the second way we can do it is this divide by 7 equals to 311 plus 1 over 7. Okay, plus 1 over 7, because the dividends needs to be divided by 7 as well, which cannot divide by 7, so that's the remainder. So I will put that into a fraction form. So just 1 on 7. So it's basically I divide 7 on both sides of this equation. Okay, so I divide 7 on both sides of this equation. It creates this equation for me. Okay, the last one. The last one is 405 divided by 7. So 4 divided by 7 is not enough. 40 divided by 7, 35. Left with 5. Okay, 7 times 8 will give you 56. So it's too much. So you can't times 8. So you times 7 here. So 7 times 7 gives you 49, left with 6. Okay, left with 6. So again, still 2 ways to write it. 405 will equals to 7 times 57 plus 6. Or it can be 405 divided by 7 equals to whatever the answer is, plus the remainder divided by the dividends. Okay, 6 divided by 7. Okay, why I do this? Because like polynomial long division will show in the same way. Okay, polynomial long division will show in the same way how we can write the result. Okay, just understand what we have done to the numbers. Okay, just what we have done to the numbers. Okay, so that's number long division. And let's have a look at long divisions for polynomials. Okay, I'm not going to teach you from the beginning because I think you have learned that in year 10. So I will start to show your examples. Okay, basically one thing you really need to remember is, first, you need to write the power in a decreasing order. So you have 3x to the power of 3, and then x to the power of 2, and then x term, and then you have constant term. And now, the dividend is x squared plus 1. Okay, another thing here is you're missing the x term. Okay, if it's quadratic, there should be 3 terms. Okay, x squared term, x term, and constant term. Okay, you don't have that x term, so you need to write 0x to keep the position. Okay, to keep the position. Otherwise, there will be some mistakes when you do this calculation. So what I will do is write 3x cubed minus 2x squared. Okay, and then x term, and then constant term. It's all good for the first one. Okay, this one will divide by what? I will divide by x squared minus 1. So it should be x squared plus 0x, and then minus 1. Okay, x squared plus 0x, and then minus the 1. You need the x there to keep the position. Okay, you need 0x there. Sit here. Okay, so now you start to do long division. So how you can do the long division? You use the first term here to divide the first term here. Okay, the first term to divide by the first term. So 3x cubed divided by x squared, what do you have? 3x cubed divided by x squared. Have 3x. Okay, you have 3x, so you write the 3x on the top. The next thing you do is, okay, so what we have done to the number long division, use the 3 to times the 9. So now you use the 3x to times the whole thing. Okay, use the 3x to times the whole thing. So I will have 3x cubed plus 0x squared. Because you don't have any x squared, you just keep the position there, the 0x squared, and minus 3x. Minus the 3x. Okay, you subtract between that. Okay, you subtract, use the top one, subtract the bottom one. Because when we do this, we use the 29, subtract the 27. So when you do subtractions, the 3x cubed minus 3x cubed become 0. Okay, minus 2x squared minus 0x squared, you have minus 2x squared. Okay, 3x and this 3x, what do I have for this two? What do I have here? Okay, it's a 6x. So it's 3x subtract negative 3x. Okay, so it's 3x subtract negative 3x. You use the top number to subtract the bottom one. So it's positive 3x subtract negative 3x. Okay, so it's a plus. So that is a plus 6x. That's why I say long division is so easy to make mistakes. You always think the sign wrong. Okay, so if it's minus at the bottom, that will be a plus because you subtract negative numbers. And then it's only 2 terms. Now the next thing will be bring this down. So you have negative 4. Okay, you have negative 4. Okay, next step, we'll use the first term here to divide the first term here. So still divide by x squared. So minus 2x squared divided by x squared, you have minus 2. Then you use minus 2 to times the dividend. So times that. So you have minus 2x squared. Okay, minus 2 times 0x is still a plus 0x. You don't really have x term. And then minus 1 times minus 2, you have plus 2. Okay, minus 1 times minus 2, you have plus 2. Okay, let's see. What's this? Okay, minus minus x squared, you subtract them, they just become 0. 6x subtract 0x, you still have 6x. Okay, what's minus 4 subtract 2? Minus 6. Okay, you have minus 6 here. Okay, so how we can express this answer? Okay, how we can express this answer? Remember, this inside thing will equals to this one times this one plus this one. So what do you write? This inside is px. So there are two ways to write it. Px will equals to the dividend times like whatever the answer you work out plus the remainder. Okay, why this is the remainder? Why I don't divide that again? Because 6x is lower than x squared. I can't really divide them anymore. Okay, so the remainder will be 1 power down compared to the dividends. So I have x squared, the remainder must be x. Okay, so that is px. Or I can write px divided by x squared minus 1 will equals to, okay, whatever the answer you work out, plus what? Plus the remainder on the dividend. Okay, so it's that. And actually I can factorize that a little bit. So it's 6 bracket x minus 1, and this one will be x plus 1 and x minus 1. So those two can be cancelled. That equals to 3x minus 2 plus 6 over x plus 1. Okay, there are two ways to represent that. That's the first one. That's the second one. Two ways to express the answer. So px divided by x squared minus 1, you have 3x minus 2. Also plus 6 over x plus 1. Do we need to turn on the light? Do you think it's quite dark? Anyone feel uncomfortable? Okay, if anyone feel uncomfortable, just let me know. Alright, let's have a look at the second one. Okay, the second one has x to the power 4, 3, but I miss x to the power 2. Can you see like I miss 0x to the power 2 here? And I have x term and then constant term. And divide by x squared, x and constant, which is no problem. So let's write this down. 2x to the power 4 plus x to the power 3 plus 0x squared plus 13x and plus 10. Divide by 2x squared minus x plus 4. Okay. First term divide by first term. I will have x squared. Okay, so it's 2x to the power 4 divided by 2x squared equals to x squared. So the first one is x squared. Then x squared will go to times with that number. You will have 2x to the power 4 minus x to the power 3 plus 4x squared. And let's subtract between that. So the first term must be 0. You have identical things. Okay, and here x cubed. Subtract negative x cubed. So it's x cubed subtract negative x cubed. That will give you 2x cubed. Okay, subtract negative numbers. That will give you positive numbers. 0x squared. Okay, you have 0x squared. Subtract 4x squared, you have minus 4x squared. Okay, the next thing will be bring this down. You have plus 13x. The next step will be using this number to divide by this number. So you have 2x cubed divided by 2x squared, that will give you x. So you have plus x here. And you use this plus x to times with that number. So it's 2x cubed minus x squared plus 4x. So minus x minus 4x squared minus bracket negative x squared, that will be minus 3x squared. And 13x minus 4x, that will give you plus 9x. And the last thing will be bring this 10 down. So have a plus 10 here. Have the plus 10 here. And then the next step will be use this one. I'll change the color. Use this term to divide by this term. What you have is minus 3 over 2. Okay, you have minus 3x squared divided by 2x squared, that gives you minus 3 over 2. So the minus 3 over 2 will go to time with the dividend as well. So you have minus 3x squared minus that times minus x is a plus 3 over 2x minus that times 4, you have minus 6 here. Okay, let's see what I'll have. Okay, the first term just cancelled, but I have 9x minus 3 over 2x. That gives me 15 over 2x, right? 18 over 2 minus 3 over 2 is 15 over 2. So I have 15 over 2x. And then you have 10 subtract negative 6. You will have positive 16. And this is a linear. The dividend is a quadratic, so it's 1 degree less. So that is the remainder. Okay, that is called the remainder. Okay, the quotient is x squared plus x minus 3 over 2, and this is the remainder and that dividend. So how we can express this answer? How we can express this answer? I'll write px equals to 2x squared minus x plus 4 times x squared plus x minus 3 on 2. And then I will plus 15 over 2x plus 16. Okay, that add the remainder. Okay, add the remainder. Dividend times quotient plus remainder. Or what I can write is px divided by 2x squared minus x plus 4 will give me the quotient, which is x squared plus x minus that. And I will plus 15 over 2x plus 16 over the dividend is 2x squared minus x plus 4. Okay, it not looks very nice because it's fraction over fraction form. So I'll times 2 on both top and bottom. Okay, times 2 on both top and bottom. So I have 15x plus 32 over 4x squared minus 2x plus 8. Okay, I have write the two ways to express that. Okay, so this two example is when I cannot really avoid long division because it's a polynomial divided by something not linear. Okay, if a polynomial divided by something not linear, you need to use long division. Okay, that's the time you cannot really avoid long division. Okay, polynomial divided by something which is not a linear. Okay, if it's divided by a linear, which will be easy to deal with. Okay, if it divided by linear, which is easy to deal with. Okay, let's look at the next example. Okay, the next example is here. I don't want to do this one first. I want to do example 4 first. Okay, I want to do example 4 first. Okay, there are a couple of things I want to talk about in this example. Okay, a couple of things I want to talk about in this example. So, when this method can be, I will introduce one method. I think it's called synthetic method. I will introduce this one. I'll introduce this one when it's a px divided by a monic linear. What is monic linear? What is monic? Yeah, Auntie? Yeah, the leading term constant is 1. So which means I just have x plus something or x minus something. It's not like 2x plus something or 2x minus something. So the leading term needs to have a coefficient of 1 and I can use this method. But like before I use this method, let's try to do this still by long division. Let's see what can happen. Okay, I'll use long division to do this quickly and to see what will happen. So x cubed divided by x, I will have x squared. And then x squared times x, you have x cubed, times 2, you have 2x squared. So x squared subtract 2x squared, you have minus x squared. Bring that down is minus 14x. Minus x squared divided by x, it will be minus x. Minus x times x, you have minus x squared minus 2x. Minus 2x, let's say 14 minus negative 14 minus negative 2 will be negative 12x. Okay, minus 14x minus negative 2x will be plus 2x is minus 12x. The last is bring the last term down is minus 24. And minus 12 divided by x, minus 12x divided by x, you have minus 12. So you have minus 12x minus 24. And they are the same, so we have remainder 0 here. Okay, that's what we will do for long division. Okay, that's what we will do for long division. So when I see this, which means I have no remainder, right? Okay, if there's no remainder, x plus 2 is a factor of px. It is a factor of px. Why it is a factor of px? Because what I can write for this equation. So px will equals to x plus 2 times x squared minus x minus 12. Right? What I can write is this. So it's x that times that. I have nothing to plus in the end. So you can see that x plus 2 is a factor of that. Because when px divided by x plus 2, I have no remainder. Okay? Which I prove that it is a factor of px. Okay. Next thing I want to do is doing this by using the method I mentioned before. I will write out the coefficient for px first. So what is the coefficient in order? Okay, let's write the coefficient in order for px. So coefficient for x cubed is 1, x squared is 1, for x is minus 14 and the constant is minus 24. So what I will write is 1, 1, minus 14, minus 24. Okay, for coefficient 1, 1, minus 14 and minus 24. And I'll put that into columns. Okay, I'll put a number here. So what will this number be? This number will be, what you're trying to divide, you're trying to divide x plus 2, right? What you're trying to divide is you're trying to divide x plus 2. So what x, I will make x plus 2 equals to 0. I'll make x plus 2 equals to 0. So what I'll put here is minus 2. What I'll put here is minus 2. So I'll put minus 2 here. Okay, I'll put minus 2 here. Okay, I'll start to fill numbers into those 4 boxes. Okay, I'll start to put numbers into those 4 boxes. So the first one, okay, after I set up 1, 1, negative 14, negative 24, and negative 2, that's all from the information I already know, okay? And now I start to fill in this box. So the first box always needs to be the number on the top. Okay, directly bring down this number, whatever is that one, you put that one down. So that is 1. Okay, that is 1. So whatever on the top, you see on the top, you bring that down. The second one. Okay, the second box will be a little bit confusing. So I will use this negative 2 to time with this 1. Okay, this green 1, whatever you work out before. And then you go to use that to plus, let's make that black, to plus that black one. Okay, that's how you work out this one. You use this one to times this one, go to plus that one. So what do you have? You have negative 2 times 1, you have negative 2, and plus 1, you have negative 1. Okay, now you have negative 1 here. I will change the color. Okay, I'll change the color. I'll change different colors. And what I will have for the next? What I'll have for the next one will be, okay, use the negative 2 to time with the negative 1 you just work out, and use that to plus what? Plus that negative 14 on the top. So use that one to times the new number just work out and go to plus the next one on the top. So you have 2 plus negative 14, you have negative 12. Okay, you have negative 12. Okay, you have negative 12 here. So what's the last one? What's the last one? The last one will be use the negative 2 to time with this negative 12 you just work out and go to plus negative 24, which is the number on the top. Okay, so use that number to times that number, go to plus with that number. Okay, so just keep repeating that process. Okay, always use the negative 2 to times the new number you work out and go to plus the number on the next column. Okay, so always doing this process. So the last one is the remainder. Yeah, that is a 0. Okay, the last box. What the last box gives you? the last box always give you remainder. Okay, last box always give you remainder. So you can see that there's a remainder 0, right? This is a remainder 0. But it's also very helpful for this 1, -1, and -12. What are they? Coefficients. Coefficients of what? Can see on the top is 1, -1, and -12, which is the coefficient of the quotient. Okay, of your quotient. So can you see, like, I just use a box and I just use simple calculations to totally replace this long division. All the information I work out in the long division, I can also see that from the box. Okay, I can also see that in the box. So which means x plus 2 is a factor. So px will equals to x plus 2. Okay, that is from here times what? Okay, so this coefficient is x cubed, and then x squared, and then x, and then constant. At the bottom, that will be the coefficient of x squared, x and constant. And the last one is remainder. So now you have 1 x squared, and you have 1 minus x, and you will subtract that by 12. And you plus the 0 remainder. You use the 0 remainder. And I can further factorize that to x plus 3 and x minus 4. I can do further factorize. You will have 3 linear factors for px. Okay, after you work out 1 linear factors, the other 2 will be easy to work out. Okay, the other 2 will be easy to work out. Okay, and then I want to show you a special case. Understand what we have done for this one, right? Remember how we do with this box. And let's go to the previous question. Okay, as I said, if it divide by linear, I don't really need to use long divisions, but like the problem here is like it divide by a linear, but it's not a monic linear. You got a coefficient of 2 on the leading term. So it's not monic. So I can still use that method. But before we can use that method, let's still do this long division. Let's see what is the answer supposed to be. Okay, I have 3x cubed plus 2x squared minus x minus 2, and I want to use that 2x plus 1. Okay, 3x cubed divided by 2x, you have 3 over 2x squared, and then you times that is 3x cubed plus 3 over 2x squared. 2 subtract 3 over 2, you will have 4 on 2 subtract 3 on 2 is 1 on 2 x squared. Bring that x, use minus x here. Okay, so 2 subtract 3 over 2x. That gives you a half x. And then squared. You use a half x squared to divide by 2x. So it is 1 on 4x. Okay, it got 1 on 4x. So 1 on 4x times 2x, you have a half x squared. 1 times 1 on 4x, you have 1 on 4x. So now you use negative x, subtract a quarter x. What you have is negative 5 on 4x. Okay, minus 5 on 4x. And bring this negative 2 down here. So negative 5 on 4x divided by 2x. That gives you minus 5 over 8, right? Minus 5 over 8. So you have minus 5 over 8 times that is minus 5 over 4x minus 5 over 8. So you have minus 2 subtract minus 5 over 8. That will give you minus 16 over 8 plus 5 over 8. That gives you minus 11 over 8. So you have minus 11 over 8. Okay, that's the result. Like it is a correct result from the long division. Let's compare this to the box method, okay, to that box. So what I can do to this box is I'll write 3, 2, okay, so I'll write x cubed term, x squared term, x term, and the constant term. So you will have 3, 2, minus 1, and minus 2. Okay, let's have a look at this table. You don't need to draw this many boxes. I will just show you one thing. So remember what number I choose to put here last time? I choose the number to make the dividend equals to 0. You divide 2x plus 1, you make that equals to 0. Your x will be minus a half. So I'll put minus a half here. As I said, you directly put down the first term, which is 3. And then this box, okay, box number 1, the calculation will be negative a half times 3, go to plus that by 2. Okay, this one times this one plus that one. And that will be negative 3 on 2 plus 4 on 2. That gives me positive a half. Okay, positive a half. Okay. Box number 2. What number 2 should do? Number 2 should use negative a half to times positive a half, go to plus negative 1. That gives me a quarter. Subtract 1 is subtract negative a quarter. Subtract 4 on 4 is negative 5 on 4. Okay, you have negative 5 on 4 here. Okay, the last box, number 3. Number 3 will be negative a half times negative 5 over 4 plus the negative 2. That gives me 5 on 8 minus 16 over 8. That will be minus 11 over 8. And you know from the previous example, okay, from this example, you know that the 3 should represent the x squared term, right? And this x should represent x term, and this should represent the constant term, and the last one should represent the remainder, correct? Should represent remainder. Let's have a look at the actual coefficient. The actual coefficient and remainder. So what's the actual coefficient? It's 3 on 2, a quarter, and minus 5 on 8. And what is the remainder? The remainder will be minus 11 on 8. What you can see the coefficient I work out and the coefficient of the actual coefficient. Which divide by 2? The result I get should divide by 2 to get the result to the actual one. So when it's not a linear, monic linear, okay, it's not a monic linear, I will divide by that coefficient or all the coefficients to make that match. So I need to divide by 2. But wait a moment, it's not every number to divide by 2. Which one is different? The remainder. Can you see the remainder? The remainder will remain the same. Okay, doesn't matter if there's a coefficient or not. The remainder is always the correct one. But what are the different one? The different one will be the coefficient of your quotient. Okay, the coefficient of your quotient. So your coefficient of the quotient all needs to be divided by the coefficient of your linear. Okay, so basically it's divided by A. It's basically divided by A, so it's divided by 2. So it's AX plus B. So you put minus B over A here, and then all the coefficient will need to be divided by A. So remainder doesn't need to divide by A. Okay, that's how you adjust your answers to make it still true. Okay, that's how you adjust your answers to make it still true. So what I can write for my px? My px will be 2x plus 1 bracket 3 over 2x squared plus a quarter x minus 5 on 8 plus minus 11 over 8. Okay, there is a remainder. Okay, there is a remainder. Okay, both long division and this box method gives me what is the quotient and what is the remainder. Okay, both things after we use this method. But is there any other way I can quickly work out the remainder without knowing the quotient? Okay, just wondering if there's a remainder or not. Okay, just wondering what is the remainder. I don't really care about what's the quotient I will have. What I can do is substitution. Okay, what I can do is substitution. So what value I can substitute? I will substitute the x can make the quotient, the dividend to be 0. So for this one, I will substitute negative a half. Okay, for this one, I will substitute negative a half. So what is p negative a half? P negative a half is 3 negative a half cubed plus 2 times negative a half squared minus negative a half and minus 2. That gives me minus 3 over 8 plus 1 on 2 plus a half minus 2. So that's minus 3 over 8. A half is 1. 1 minus 2 is minus 1. So it's negative 3 on 8 minus 1. That gives you minus 11 over 8. So the remainder, it is minus 11 over 8. So to find remainder, I can directly substitute the number which can make your dividend equals to 0 to quickly work out the remainder. But the disadvantage is you don't know your quotient. You only have one information. But for the long division or the box method, you can work out the quotient and the remainder. Okay, two things. Any questions about this? We can also find the remainder for this one. So I'll divide x plus 2. So I will sub p negative 2. I'll divide x plus 2. So I need to divide p negative 2. So negative 2 cubed plus negative 2 squared minus 14 times negative 2 minus 24. That is minus 8 plus 4 plus 28 minus 24. Okay. Minus 8 and minus 28 give you positive 20. 4 and negative 24 give you minus 20. So that is a 0. That is a 0, which means there's no remainder. You have 0 remainder here. Okay, Okay, so this I do a lot in this example. Okay, I really do a lot in this example, but I want you to understand that. Okay, I want you to understand that, and I want you to see this advantage of this box method compared to long division. It like can not only give you the remainder and also give you the quotient. Okay, it's really quick to do. What is the remainder theorem? So the remainder theorem will be px divided by ax plus b. When you sub negative b over a, you will find the remainder. What is the factor theorem? If you divide by ax plus b, then like ax plus b is a factor of px when the remainder is 0. Okay, when the remainder is 0, that will become a factor. What happened here? I don't know what happened here. So just take off the last line. You don't really have. I'll go to check what happened to my word. So if ax plus b is a factor of tx, then p negative b over a must be 0. Okay, find the remainder when this equals to 2. Okay, one thing I want to talk about is, I know you want to substitute p2. Even though you substitute p2, it's still quite hard to calculate because you write 2 cubed minus 3 times 2 squared plus 2 times 2 plus 6. Okay, and then you will say 8 minus 12 plus 4 plus 6. What I'll have is 6. Still need a couple of steps. Let's compare. I'm not sure which way you will think is easier, but like I will really prefer to use this box. I have 1, negative 3, 2, and 6, and I want to divide by that, so I'll put 2 here. Okay, I can really quickly do this. That's 1, 2, 1 times 2 is 2, 2 minus 3 is minus 1, minus 2 plus 2 is 0, 2 times 0 is 0, 0 plus 6 is 6, and you know the last box must be the remainder. And you can also work out remainder, which is 6. It just depends on which way you think is easier for you to do. You can substitute the number, or I can set up this table and work out both quotient and the remainder at the same time. I'll keep using this method to make you familiar with it. Okay, next one. Px equals to that divided by x plus 1. So you will put p negative 1 into it. So it's negative 1 cubed minus 4 times negative 1 squared plus negative 1 plus 6. I will recommend you to write out the step. Do not start calculation directly to put negative 1 in your head. You start to do the calculation. I will recommend you to write out the first step because you can make some mistakes. You may make some mistakes in between. And if you don't write the first step, I don't know where to give you consequential marks. You will give at least 1 mark when you write out that if it's like a 2-mark question. So make sure you get something. Okay, make sure you get something. So you have minus 1, minus 4, minus 1 plus 6, and you have a 0 here. But let's say instead we use this way. 1, minus 4, 1, and 6. And you will have minus 1. And then 1 minus 1 plus minus 4 is minus 5. Minus 5 times minus 1 is 5. 5 plus 1 is 6. Minus 1 times 6 is minus 6. Minus 6 plus 6, which is 0. So that is the remainder, and your remainder is 0. The conclusion I can make is x plus 1 is a factor of px because I have 0 remainder. Because I have 0 remainder. Any questions about this? I think it's all good for this. Okay, next thing. The next thing is how to factorize quadratic. Why I say quadratic? Why I put quadratic at the beginning? Because quadratic is something different compared to cubic or quartic. I will factorize quadratic by a different method. Okay, by a different method. So how we can factorize quadratic? How we can factorize quadratic? Okay, the first thing we'll think about whether this quadratic can be factorized or not. Okay, is it possible for me to factorize this quadratic? Should we start directly to factorize it, and after 10 steps we find, oh, I can't factorize anyway? So we need to test at the beginning whether it is worth me to try to factorize it. So how we can try to how we can know if it can factorize or not? So we have ax squared plus bx plus c to factorize. Then I have discriminant is b squared minus 4ac. So the first thing is check about this discriminant. If that is smaller than 0, I cannot factorize. Okay, I cannot factorize for sure. You don't need to even try. If you can say discriminant is smaller than 0, then just stop. Okay, you don't need to do anything to that. This equation cannot be factorized by method student. Okay, special students will learn something else, but method students will stop here. Okay, we don't factorize. Okay, we just stop. Okay, so we cannot factorize further. But if it is greater than 0, which means it can be factorized. Okay, it can be factorized for sure. So how we can factorize that? There are 3 different cases. Let's think about the first case. Okay, think about the first case. The first case is the easier thing. We miss the middle term. We miss the x term. We just have ax squared minus b. Okay, miss the middle term. So this b must be greater than 0. Then we will use the formula a squared minus b squared equals to a plus b times a minus b to factorize. Okay, directly use the formula. So what we'll have here is, I can do that 2 times x squared minus 8. Well, I can do 2 ways. I can do first square root 2x squared minus 4 squared. Okay, square root 2x squared minus 4 squared. And that is square root 2x plus 4 and square root 2x minus 4. Okay, I can factorize that way. Or what I can do is take 2 as common factor, 2x squared minus 8. And what 8 is? 8 is 2 root 2 squared. So it's square root 8 squared. And square root 8 is 2 root 2 squared. Then I will have 2 times x plus 2 root 2 and x minus 2 root 2. Yep. Both can be correct. If I make that equal to 0, I will say this one is easier for me to solve. I have a single x there, it's easier for me. But like they will have the same result and all correct. Okay, for the next one, can you see like there's 3 and there's a 75, and I will think about take the common factor. So 3 is the common factor, and then x minus y squared minus 25y squared. So what is 25y squared? It's 5y whole thing squared. If you want to use a squared minus b squared formula, it must be the whole equation to be squared, like whole a squared minus whole b squared. Okay, it can't be like a coefficient times something squared. Can't use formula at that time. So it must make that 5y whole thing squared. And that gives me 3x minus y plus 5y and x minus y minus 5y. And that gives me 3x plus 4y and x minus 6y. Okay, the next thing, like this is easy to factorize, and the next thing I will think about is cross multiplication. Okay, I can cross multiply them and solve that easily by separate the coefficient for the first term and second last term to make that to become the middle coefficient. So for this one, I have coefficient of 1 for this term and have constant of -8. I want to make 1 and 1, and I'll have -4 and 2, or 2 or -4. I'll cross multiply them and plus them to make the middle term. So the middle term is -2, which means I've successfully factorized it. So I have x, okay, read it horizontally. So it's x minus 4 and x plus 2. Okay, x minus 4 and x plus 2. So it's the coefficient of x, and this is the constant. And you read that horizontally. Okay, for next example, I have 15x squared plus 11x plus 12. Okay, I don't want to really see negative in the first term, so I'll take a -1 out. So I'll have this. Okay, 15. So what 15 can be? 5 and 3 or 1 and 15, right? 5 and 3 and 1 and 15. Normally it will be the two closer number. It's not very likely to be 1 and 15. So I'll choose the middle two. So 3 and 5. Factorize that. 3 and 5. And I'll factorize this. So aiming to make a -11. Let's just like normally do it, like 3 and 4. Let's make 3 and 4. Cross multiply them, you have -15 and you have a 12. You plus them, that can only give you -3. It's not -11, which is not correct. So how about I change this? Let's put -4 and 3 in this way. Okay, that gives me -12, that is plus 9. That gives me -11, which is correct. I have made the middle number. So that will give you, okay, the minus is still in the front, and you have 3x minus 4 and 5x plus 3. Read it horizontally. So that's the coefficient of x, and that's the constant. Alright. Example 4. Okay, example 4. Completing the square. Okay, why is called completing the square? Why I'm not using the first or the second way? Because first, let's test the discriminant. The discriminant is b squared is 64 minus 4 times 1 times 1. That is definitely greater than 0, which means I can factorize this for sure. But I have coefficient of 1 and coefficient of 1. 1 and 1 you cannot make an 8, okay? Not enough to make 8. So I will use the completing square method. If like all other method cannot work, completing square is your friend. Okay, use that one. So how we can use that completing square? I will keep the first term and keep the second term. Okay, keep the first term and keep the x term. I will add half of the x term, so it's 8/2 squared. And I need to subtract that number as well. Because I don't really have that number, I add that, I need to subtract that again. And don't forget you have the +1 as well. So you have the +1 there. So what I will have is, this 3 can be combined and this 2 can be combined. For this 3, what I will take is the x, the sign, and the number. Okay, you take 3 things from the 3 different terms. You take the x, the sign, and the number. So what's that? X minus 4 squared. Okay, minus 16 plus 1, so you have a minus 15. So minus 15 can be written as square root 15 squared. Why I want to put that into square root 15 squared? Because I want to use a squared minus b squared formula. Then I will have x minus 4 plus root 15 and x minus 4 minus root 15. Okay, for the next one, like, can we factorize it first? Let's think, can we factorize it? Discriminant equals to minus 2k squared minus 4 times 1 times 1. That is 4k squared minus 4. Right? 4k squared minus 4. And that equals to 4k squared minus 1. I need that to be greater than 0, which means I'm trying to solve inequalities. Okay, I need that to be greater than 0 first, and I can factorize. Otherwise, I can't factorize. So k squared minus 1 needs to be greater than 0, which means it's k plus 1 times k minus 1 needs to be greater than 0. So at what case k... Okay, that's a minus 1, that's a plus 1. I need that to be greater than 0. I can equal as well, greater or equals to 0, because it can be equals to 0. So you have here and here. Okay, the corresponding x will be here and here. So what is the solution for k? K will belongs to R except -1 to 1. So what is the requirement? I just need my k value cannot be the value in between -1 and 1. Okay, so if k equals to all the rest, then I can factorize this. So how we can factorize that? Okay, that is x squared minus 2kx plus half of b squared and minus half of b squared, and you plus 1. Okay, half of b is k and you square it. So it's k squared and you subtract that. And for the first 3 and the last 2, you will have x minus k squared. Right? X minus k squared. Okay, now I want to make my constant. I have 2 ways to do it. I'll ask you which one is better. I'll be minus k squared minus 1. Okay, that's my first way. And the second way is plus bracket 1 minus k squared. Which one you prefer? Which one you choose? Second line or the third line? They're the same, but which way you will put that in? Why first? You can't be the second. What's your purpose? What do you want to do? You want to factorize. Yeah, you need to use a squared minus b squared. Okay, you can't have the plus. If you have the plus there, what you can do? You don't know, you can't do anything. So you need to have the minus there. Okay, you need to have the minus there. So you will make that a minus square root of that. So that is x minus k plus that, and x minus k minus that. Okay, otherwise I cannot factorize. I need the subtractions. I can't have the plus. Yep.